first of all, the look of how we do things here is going to change a bit. Going forward with the distance learning piece that we do in conjunction with these classes that I teach, the feedback that we have gotten is that when I do the classroom video stuff in Aspen, it's distracting because students wind up wanting to know more about what you're doing and what's happening in the class versus what's happening up here. And when someone has a question, they can't hear it. If I forget to repeat the question, nobody knows what we're doing. It stops things. It's not like what they want. And so what the people want is they want what it is that I do in New Orleans when I'm there, which is what they refer to as a combination of the Big Bald Man and Khan Academy. So that's kind of what it is, where I start, with my, flapping arm antics with things. And then I switch to stuff where it takes your attention to a screen. I can draw and this and that, and we do, all this other stuff. And then I come back if there's something for me to emphasize. Then I go back to the screen, all that. That's what works best for everybody else. So what I'm going to have to do is make that work a little bit better. And once I get more videos done in the can to do this, then my goal is to be able so that once I have those classes in here, which, by the way, this class no one else is taking because those people aren't there yet, is to be able to come in here and just teach the class for you. But then those days that I'm not here, this is what you get. Kind of a thing. So also, right now, if you were to look at this video, it would be a very poor quality video because the screen image back here is so bright, the camera throttles it back and it makes me very, very dark. It looks like I'm in some kind of a shadow. In order to keep the brightness and the color levels stable there with the camera, I'm going to have lights like I have at my studio in New Orleans here to kind of shine on me so that I'm bright and yet try to have them positioned so that they're not distracting for you guys. And so those are coming. The new board that we have, thanks to the grant that we have from American Airlines, the new board have how I'll be able to do the switching stuff with what I do. All of that is going to change, and it will mean something a little bit different for just the videos that I do, but it won't have an impact on what I do here for you. My point is this, is that my goal is to create still kind of this hybrid thing for you guys, is so that you have the distance learning element on the one hand, and then you have me live for better or for worse on those days when I'm here. In the next 10 days, I'll find out kind of more the direction of how this is going to go for our program. And as such with that, it will dictate how much I'm actually physically here for the balance of this semester.
Okay.
That's just kind of the way it's gonna work.
Do you have,
I don't. I don't know if it's going to be 50-50. I don't know if it's going to be 40-60.
okay.
I don't know. But I know that in order for me to have the number of these course videos in the can, as it were, and I hate that canned thing, but that's just how it's going to have to be. By July 1, to give you an example, in this class, there are 43 course videos. There are 32 sim videos. There are not as many how-to videos because you've already had that here for this. that's like a lot. And so what I'm doing is that when I start doing that production for the commercial side of things, I will actually then, as I build that, I'm going to build the back half of the class first to start those, and then I'll backfill in with the front stuff leading up to it, so that in those times, Ellie, that I'm not here, I'm not slowing you down.
Perfect. Sounds good.
That's what I'm doing. That's my goal. Side note, did your dad tell you I adjusted the covering on your airplane?
He did, yes.
On the diamonds, we have these straps that connect to the covers at the front, and you snap them in, and then there's a strap that's got this rubber-coated hook that goes inboard of the flaps on the trailing edge of the wing right next to the fuselage. And it goes over the top of the wing, connects here, and then you snug it up with that. Just based on the way that your nose of your airplane works, the only thing that you could do, you tighten it to the point that you're basically counting on the antennas of your airplane holding that cover on. And that would make me really nervous, you know, to be able to do that. And so I think that kind of a tie-down thing, because Bruce's custom covers, they're the ones that did ours too, they have that solution. And they should be able to do that for your airplane.
For sure.
So,
Sounds good.
yeah. And the other thing that I did is on that front one, that front strap had slipped underneath your nose geared door of that.
It's always fun.
So I moved it behind the gear door and above the gear, and catching it on the actual strut itself, the nose gear strut, with this to keep it from going any further forward on that. But that's probably not the best solution either. But anyway, enough of that. VORs.
All right.
All right, so picking this up here, Ellie, in just this review of VORs, this is the part here now where your part of this is going to be accelerated more so than the other class. So this is now where you get your own deal. Yeah, yeah. Okay, so remember, the VOR is the transmitter. You've got this box in your airplane. This VOR receiver is the box in your airplane that puts a display somewhere over here showing you what's happening with your VOR. Remembering that your VOR display is not heading sensitive. If you could put that airplane on a pin and just spin it when you're on a radial like that, your display image will never change. It won't change. So it's a combination of understanding how you're using that VOR. Are you using it for to and from navigation to stay on a Victor airway? Are you using the VOR to know when you're crossing a particular radial for location assistance? You can do that. The whole point of this is to remember how you program this in so that you get the appropriate sensing with your to or from indication. And to understand that if you're not on top of the programming of this, you could find yourself in a situation where you get reverse sensing as opposed to normal sensing. And remember that reverse sensing would be if you are going away from a VOR with a to indication, your CDI could get offset to your right. And in normal situations, you know that your CDI, your course deviation indicator, is your course. That's your course. And if it's showing you that your course is over to your right, go get it. You steer to the right to go pick up your course. Well, if you're going away from a VOR with a 2 indication, you may wind up with reverse sensing. You could have a deflection off to the right and you think, okay, I'm going to go get my course. But with the reverse sensing, you're just going to keep going further away from your course. So you have to remember which way is which and when you're getting reverse sensing. In the G1000 units, you won't get reverse sensing. They're set up so that you won't. But in the old-timey systems, you still could. That's the point there. Preparing this for use, we always want to make sure, even if we're launching on a GPS flight plan, that we know how to use our VORs, that our VORs are working correctly. There are things that we can use, that we can do on the ground to make sure that they're working correctly. That's in those five bullet points. We also know that if we're using a VOR for IFR flight, that every 30 days we are responsible for checking that VOR to make sure that it's working correctly. And there are several different tests that you can do every 30 days, but you've got to have that appearing in the flight log when you're planning on using that airplane and the VOR system for IFR flight. You should always, as long as the VORs are working and as long as we have a VOR system in our, in our nation's airways, you should always plan on using the VOR, because you think about GPS as being so foolproof these days, but you may be flying in an area where your GPS signal may not work. If you're flying in some places in New Mexico where they do a lot of military activity, they will shut that GPS signal off so that they can't use it. And you have to know that. You'll know that in the NOTAMs, and to know that you're going to have to rely on VORs. So in order for that to happen, you have to have these checks. So the VOT check on this facility, you've got to be able to do this. These bench tests like these, you have to have a plus or minus 4 degrees to make sure that everything works correctly on these. And you can look at those and see what all of that is. A ground checkpoint. Again, something on the airport where you taxi your airplane on a particular compass rose, you line up with that, you tune to a particular VOR, and it'll give you either a 360 or a 180. You tune that in, make sure that everything is lined up, you're good to go. With that, you have a plus or minus 4 degree. If you're going to use a certified airborne checkpoint, so for instance, if you fly west of a city and over this lake may be a certified airborne checkpoint to a particular radial on a particular VOR, they give you another 2 degrees of slush factor, so that has to be plus or minus 6 degrees from an airborne standpoint, from a checkpoint. So you have to know that. The dual VOR check, this is the one that's probably most common. It's the one that I do on my airplane. I'll tune into a VOR. I'll tune both VORs then onto the same course or radial of the VORs, and I will check them against each other. And what I'll do is for instance, the one that I do around here is I'll get out in the practice area, or if I'm coming in from rifle or whatever, I'll make a turn to the north so that I'm on a northerly heading, and I'll dial in the red table VOR on both VORs. So as I'm looking at this from my perspective, here I am going north, and I see both my needles pointing off to the east, and my number 1 VOR is bracketed by the number 2 VOR, and normally it's just dead on with that. There's 0 degree plus or minus on this. They're both reading the same, from that distance. So that's the one that I use most often. There's another thing here. It's not a required check, but it's something that we used to do in the old-timey VORs with this, is that we would actually want to swing that CDI just to make sure that we're getting a full-scale deflection on these things, and to find out make sure that we'll get it dot to dot, if you will, all the way out. And that's what you can do also on this. It's a little weird because, so many times, especially when you're tuning that in, to do that, maintaining that heading and not wanting to chase that needle, because, as a pilot, you just want to keep everything centered. Well, you know, that's, anyway, so there's that. Orienting, using a VOR. A lot of times people say, well, now wait a minute, you know, how do we use this, you know, if we're on a GPS flight plan, what the heck? And the example that I use is I will use, okay, in your radio now you hear this, November 141 Hotel Lima, say position. So what do? So if you're in that situation, do you give them a Latin lawn of your GPS? No, because they don't have any way on their screens to know what that is. Do you tell them how far you are from your destination? You know, because you can't do that. Let's say I'm going to New Orleans. I get over the hump over here near What just happened? Did we just lose power here? I don't know. I'm still showing live. Well, there we go. I don't know what happened. Nutty. You know, if I get over to Colorado Springs, they give me direct New Orleans. They said, you know, November 504 Hotel Lima, we can give you direct MSY. I'll take it. Boom. 5 minutes later, somebody comes up and says, November 504 Hotel Lima, say position. You know, what do I tell them? You know, I'm 820 miles northwest of New Orleans. Not helpful. So with that, this is another thing where we can use VORs. And we can tune in to the nearest VOR, which we should be tuning in underlying a GPS signal anyway. We should be staying up with those VORs. To have at least one VOR within range anytime that we're flying on a flight path, even if we're a GPS direct and we're off Victor Airways. Because in this case, you can tune in to whatever VORTAC that happens to be in figure 17.20 and tune that in, turn your OBS or your course needle until it centers, and you can either read the tail or see what this is to know what radial that you're actually on. In this case, of course, it's the example is showing that you're on the 254 degree radial here at approximately whatever that's going to be, whatever the DME is. And you can say you're northbound crossing the ABC VOR 154 degree radial at 13 DME. They know exactly where you are now. So that's what it is. Now, with ADS-B, once that fully comes into play, they are always going to know where you are. Because your aircraft, for instance, you know, my airplane here, and yours as well, I'm sure has ADS-B already plugged into it like that, is that they know the type aircraft, make, model, they know who's flying it, they know, you know, they know everything about that airplane because it pops up. So they don't have to ask where you are, you know, and so, but, you know, in case they do, there you go. Triangulation, using two radials of two different VORs to identify a fix, to know where you are. That's what they're showing here in figure 17.21. Flying a DME arc is another one, being able to fly that arc, but to identify the lead radial that you know where you need to begin your turn to intercept your inbound course for a particular approach that you may be flying. If you're homing in on an NDB, providing that you have ADF radio in your airplane, which who does anymore, you can use that to kind of refine your position based on where you think you are with that NDB, the non-directional beacon, and using that VOR to get you where you're going, identifying the radial. This figure 17.22 tells you how to do that with this, and it's pretty straightforward with that. And the DME arc. The big thing with the DME arc, and we're actually going to go through DME arcs when we get more into the approaches here as well. Some autopilots can actually fly those arcs like that. Some autopilots can only offer guidance on these things, and so with that we go to the, you know, twist 10, turn 10 mode of flying a DME arc, and we'll talk about that when we get back to it. Trying to turn these. One of the things that I've noticed is that when they have these images, like and I don't know if it's a JPEG file or whatever that it's going to be, but it really slows things down when I'm trying to move this thing. Fixing a position over a VOR, it's the two things that are really important here is number one, as you're approaching that VOR, when you get within, I'll say when you get within, God, it depends on the type of VOR receiver that you have in the airplane, because there are some of them that are pretty fidgety when it comes to that needle wanting to waltz around when you're flying over a VOR. Normally it's like within 2 miles, you'll start to see that CDI start to move a bit. The big thing is that once you get closer to that VOR, and I'll say within 2 nautical miles, you'll start to see that VOR thing start to move around a little bit. It's important to have established a wind correction heading to hold whatever course that you want prior to getting to that cone of confusion. Once you get into that cone of confusion is when that needle, that CDI, is going to want to wobble around. Don't chase it. Do not chase that needle, because you'll just be doing this over the VOR. What you're looking for is you're looking for the flag flip. You're looking for that thing to flip to know that you have crossed that VOR. And if you're continuing on a particular airway that still holds you on that same heading, you're going to get everything that's going to switch now to a from indication, and you have already tuned it in to the back of the VOR. Now from that you're flying it from the front, and so you wouldn't have to change anything, and to get the appropriate course guidance as you go away from that station. If you need to make a course heading, a course change to pick up a different Victor airway from that. Let's say that you're flying, from the west, and so you're flying here and you have a 2 indication on 090. You're flying the 270 degree radial. You're coming to the VOR, you get the flip, and then from that point you're supposed to turn right, and you want to fly the 135 degree radial outbound. So you do that first with heading, and you get your turn started first with that heading of 135 degree outbound, and then as you establish on that heading, now you start changing your OBS so that you get that 135 degree with the from indication there, and then by this time you're 1 mile or 2 miles out. You let that stabilize. Now you can use your course deviation indicator to fly away from that. But it's that cone of confusion, is that when those flags get a little flippy, and you lose that to from indication momentarily until it kind of gets back its senses. No pun. Passing a beam, a VOR, with whatever radial that you need to know, with whatever it's going to be from a position standpoint here as well. If you look at the example here on figure 17.25, what you're looking at here is that you're looking at a situation where you're navigating here with a from the front type of a navigation technique. You could go to the back, but in this case they're doing it from the front. And I'll show you this here, and I'll just, pardon me whilst I illustrate. So what they're doing is they're using this indication here from the front side of that compass rose, picking up that 260 degree radial. And you'll notice that it's got the from indication. So, here you have your traditional flags, and in this case, you're doing it with the from indication. It's showing a deflection to the right. It's showing that your course needle is over here to the right. Right or left, you kind of have to remember kind of which it's going to be. If you have a from indication with it, your CDI is going to deflect to the side of the VOR. If you have a to indication, it's going to deflect on the opposite side of your VOR. It's kind of weird. as you're going to intercept that. As you get closer to it, here with this from indication, that CDI needle will get closer and closer and closer, and it'll center. It'll move fast or slow depending upon how far away you are from the VOR. If you're close to the VOR, it'll move fast. If you're far away from the VOR, it'll move slow. And then once it centers, at that instant, you are crossing that 260-degree radial. Even though that you're kind of headed north-northwest, that's you know, there you go. All right. You have a bearing change triangle. We don't normally teach this, and one of the reasons is because most of the equipment that we use right now, we kind of cheat and we sort of don't need it. There will be things like this that we will do, however, in the navigation portion. Once we get to the commercial side, we'll start doing more of this algebra here. Crossing a known radial from an off-course VOR. You know, this again talks about the same thing. Just remember that in that from indication, that needle, your CDI, like right here, is going to point toward that station. Whereas if you were doing this with a to indication, your CDI would be deflected over on that side. So, but just know that when it centers, you have crossed whatever radial you've dialed in, regardless of your heading. Oops. If you know your distance from the station, you can triangulate the distance in degrees, and you can do this mathematically. You can also do it on a map to note the distance between certain points in an off-course VOR triangulation piece that you can use. So you can do it a couple different ways. You can do it mathematically, you can do it by the chart. The purpose of this is to know kind of exactly where you are. The chart method actually shows you exactly where you are, and that's really what you want to know. It's kind of what I prefer. So, you know, there's that. Now, this is getting into orientation without altering your omni-bearing selector or the indication that it's giving you. The FAA, this is one of the test things that they do to kind of test, you know, whether you know where you are, is they'll say here's a VOR tag, and they'll say, okay, your airplane has the following indication, and they'll have a little scattergram of airplanes out there, and they'll say which airplane would have this indication. And these are some of the test questions that you had from last year. These are going to be kind of the same. So again, as you look at this, the best way to do this is to kind of, you know, look, number one, at the illustrations that you have on your test prep stuff, but then to also kind of project, okay, if I'm over here and I'm looking at this, how would this look? And then verify that with what you see on the question. And if it's different, try to say, okay, where was it that I might have messed up? And then if not, ask me, and we'll get it squared away. Okay, so yeah. So in this case, if you look at this, your indication that you have here is that you want the 340 degree radial with the from indication. So in this case, normally, it's like you're flying away from that station. That's kind of where it is. So this is a normal sensing situation. And what is this illustration telling you? It's telling you here that your CDI is deflected off to the left. The CDI is your course. That means in order for you to go get your course, you're going to need to turn to the left to go get your course. Okay? So in that case, the only place where you would have that left deflection with a from indication is going to be in that quadrant. Because remember, here's something else that happens, and this is something that I'll illustrate here, is that let's say that you were perfectly on course. Remember what happens when you cross anything here that is going to be perpendicular to your actual OBS radial that you have dialed in. If your airplane is over here and it's flying this direction, it's going to get that flip. That to from flip is going to happen when you cross whatever perpendicular radial that it happens to be to or from that VOR. So that's where you get the little flippy. Okay. Erase that. Here I can erase this by just getting rid of that. All right. And this is kind of what it's showing here, is that it's showing kind of the why that works here again using the perpendicular radials from there. So, if you're thinking here in this quadrant, I love that noise that the belts make on nice vinyl. So, here's another way to think about this. Don't think about the illustration as a whole. Think about, this is what I'm seeing in the cockpit. I'm flying, let's say that I'm flying roughly eastbound. That's the direction that I'm flying. I have 085 set up as my OBS with a 2 indication, right? With a 2 indication. But I'm showing a right deflection of my CDI. That means I'm left of course. Well, if this is my course here, I know I'm left of course. And the fact that I still have a 2 indication tells me that I have not crossed that perpendicular line there from that 085. This would be the only logical place that that indication could be found. All right. Tracking using the VOR. Okay, now, Ellie, let me ask you this. This is the first time that we're talking about how to actually use a VOR to get to it. Can you imagine all of this other information that we have covered thus far if I had not explained to you up front how this sucker was going to work? How ridiculously lost you would be if all this other stuff had not happened. I know.
It would have been madness.
I know. Cats and dogs living together. Total chaos. So it's the thing that I don't know why they don't think of things like this more logically than they do. There's so much of this, cart before the horse stuff, and it's maddening. Okay. So here's how to use a VOR, Ellie.
Okay.
Oh my God. Yeah. So that's kind of how you do it. Select your station, make sure it's the right station. Tune into the channel that you want or your radial, and then there you go. Yeah. So in this case, they're using this illustration to track to a particular VOR-TAC. They're going to be on the 210 degree radial tracking to the back, using 030. And that's kind of what it looks like. Determining the wind correction angle when you're tracking a VOR. A lot of times with this, you'll have a pretty good sense about what that wind is going to be. But there's several different ways that you can do it. The first thing is that you turn 10 degrees. Is that holding it? Is it too much? If it's too much, go 5 degrees. If it's not holding it, turn 20 degrees. If 20 degrees is a little much, go to 10. Go to 15. Tune it into 12. That's kind of how you do it. So, and the other thing that you can also do is that you can also get an idea before you launch. You're going to know what your winds aloft forecast is going to be. If you know that you have, if you're tracking to the northwest and you have a westerly wind of 30 knots, you already know that I'm going to need some form of a course correction here. It's going to depend on what kind of true airspeed you're generating though. So it's like you're going to know, okay, I know already right now I'm probably going to have to be 15 degrees, left, to hold my airplane in that course. That's where I'll start. And then we kind of tune it in to hold it and just kind of see where it is. And then, oh, by the way, by the time that you get this all set up just nice and perfect for this 30 knot wind, a little bit further north, it's only 20 knots. Oh, okay, I'm making an adjustment. That's what you do. Tracking from a VOR, from the front. There we go. Same thing, so that you get normal sensing. For ease of operation, use the CDI as a command instrument. I've always found this concept to be a little odd to me. I don't know why, but you can do it. So they're talking about this in using it so that you don't get reverse sensing. The non-command piece is where you have allowed, or for whatever reason, there's some reason which I still don't know, why you would want reverse sensing. But in this case, you know that when you go away from a station, and if you're using this from the front, and you're using that one, in this illustration, you're using that 140 degree radial, on your way outbound with a from indication, you're going to have normal sensing. In this case, right there where it's showing the command piece over here, is that you have your left of course, your course is to your right, go get it. That's what you want. Unless you have something here where you're actually doing some kind of a parallel offset. More on that later. Because there are certain approaches that you're going to look at where a parallel offset might be preferred. However, you can set that up on your GPS as well. You can set that up on your G1000 to do parallel offsets. So that can happen GPS-wise also. Bonus. Tracking to that station there on 320, the command to the station, getting correct sensing versus reverse sensing. And that's what they're talking about there. How are we doing time-wise?
It's 9:40, so we have
10
10 minutes.
minutes, and then I show you a slideshow.
It's going to be great.
Woohoo!
So excited.
Okay. On this illustration here, LA, what they're showing, if you'll remember back from like the instrument stuff, in order to begin an instrument approach, in some cases, depending upon how you are approaching that VOR, you're required to do a procedure turn. And in this case, it's a little different, kind of a teardrop turn that it's using here, which is a little kind of different, but because it doesn't tell the whole story. But in this case, you're tracking it outbound correctly from the front, 160 from the front. And then when you get to the appropriate mileage away from that station to begin your turn back in toward that station, then as you're making your turn, you're doing it basically by heading, because you know that you're going to, in essence, reverse course, you know, almost come back to where you were. At that point, that's where you use your heading indicator while you're making your adjustment on your OBS. Because what you're going to want is you're going to want to come back to the back so that you have normal sensing. And that's what they're showing you here in figure 17.39. This, useful. Knowing where you are, knowing where you want to go, that's kind of the whole point of flying, I think. And so how can we do that using VORs? This is sort of what they're talking about, which, by the way, is what I've been talking about. Just saying. So in this, you're selecting an outbound course. You're coming in from one way or another. You are, because they do have, it's not really a Victor airway, but they do have kind of this off-course recommendations that they have whenever they're trying to get you to cut a corner or kind of to stay away if you're making a course change away from a station at a particular area, so that you don't just clog up the airspace over that particular VOR, so that you don't have to go all the way to the VOR and then make your turn. In this case, you get to a certain distance from that, then you make a heading change to intercept your course away. So again, as you're looking at this, doing this in a normal way, you're going to be on the 170 degree radial, tracking to the station. So to the back, 170, the reciprocal, tree 50, to tree 50, tracking here. Then you're going to make your turn, and in this case, you're turning basically at a 45 degree turn. You can kind of whatever your heading requires, to go pick up the 090 degree radial to go east. So in that case, you set your heading. You set your heading with a from indication from 090, so from the front of what that's going to be. Now again, your deflection is going to be here toward the VOR side, which you expect. Once that needle starts to get centered, when you get within, depending upon your distance from the VOR, when you get within half a dot of centered is when you begin your turn to intercept that VOR. So that as you begin to intercept that VOR, bingo, you're just right there, just, you know, of course, depending upon wind correction angle, you can do it. If you're having to make less than a 90 degree turn here in this wind consideration here right there, you may not need to start it as soon. Or if your wind is different from the opposite direction, you may have to start it sooner. We do this all the time. Intercepting an inbound course. With this, we see this, Ellie, a lot. On paper, but most of the stuff that we get are going to be, we're going to get vectors. ATC is going to give us vectors with this. That said, we don't want to get sloppy and kind of not understand what they're attempting to do for us to be able to kind of get us set up for the inbound course. In some of the procedures, it actually may be spelled out. This is what you're going to do and this is what to expect. But in other cases, what they're going to do is they're going to give you what they need from you, basically. That's what they're going to ask you to do. And depending upon traffic, depending upon weather, depending upon, you know, phase of the moon, I don't know. That's kind of what they're going to give you. The purpose of what they're showing you here is to say, here's how this might look. Showing, again, using this 050 degree radial that they're using here with this from indication, getting ready to make your turn. In this case, they have a to indication that they're already getting set up so that you know that with that 2 indication now, that course deviation indicator is going to be set up opposite of your course line here with this, to bring you back so that when that centers and it begins a half a dot in, it starts bringing you back around to set you up with what you're going to want to go to the station anyway, which is going to be that reciprocal to the station piece of to the back of 190 for you to track the 010 degree radial inbound. Clear as mud? All right, there we go. You're very patient. Okay. All right, this is where stuff gets confusing. An RMI is another arcane instrument that is seldom seen in an airplane. They used to see them quite a bit, but we just don't have them. They have kind of gone the way of the dodo bird and the ADF. There's still some of them out there, but there are very few of them out there. And what it involves is that it involves, basically it's a homing needle that'll point to the station. That's kind of what it does. Almost like a bearing indicator. So you can see what they're doing here right now is that you have one that's pointing to an NDB. That's all it can do. You have the other one that is dialed in to try to pick up an inbound, a crossing radial to or from the station. And that's what they're trying to do here with this. I don't know. I'm trying to remember if we have any questions at all that involve an RMI.
Not that I know. I know that there's like a section for it in prepware, but I don't think it has any questions. I think it's like RMI or like 0.
I think it kind of talks about what it is. I don't know that there are any FAA questions with regard to an RMI. I don't believe there are.
Yeah, I don't think so because I don't remember.
Yeah, I didn't think so.
Yeah, it's in the IFR section, but there aren't any questions about it. It's just like there.
Okay. Moving on. HSI. Remember that an HSI is a heading indicator that has some form of navigational overlay within that instrument. It can be GPS, it can be VOR. That's what an HSI is, a heading indicator with some form of navigation overlay. So when we look here at figure 17-45, they're talking about this as always a command instrument. And you can kind of see, it's basically the way that our G1000 works. Excuse me. It's basically the way that our G1000 works. And so this is more applicable to our situation, no pun. Wait, see what I do? I have a gift. So with this, you can see that you have, of course, whether it be VOR, whether it be GPS, it'll also give you with this vertical navigation information over on the right side. So it'll show you here again your glide slope. And again, your horizontal is going to be your CDI. And so that's kind of what we do with this. This is an instrument that you are familiar with. tracking using an HSI. I mean, it's so, pretty straightforward. There's chapter 17. Woohoo! VORs! Yes! Okay, quiz.
Great.
Yes, quiz on VORs.
Wednesday.
I don't have you tomorrow, do I?
No.
So Wednesday.
Great.
Wednesday.
And then next week, I will be here Monday and Tuesday. I will not be here for the rest of the week.
Quitter. No, I'm teasing. Teasing. Okay. I remember you saying that. You're here Monday, Tuesday, and then you gone. Okay.
And then I'm missing the Tuesday that we get back, because we have Monday off in April, and then I'm not going to be here on Tuesday. But I will be here for the rest of the week, and then I'll be here all through April, I think. Maybe depending on how much my parents love me. So, how much they're willing to devote time to my birthday.
Just please let your mom and dad know that again, when they're ready to adopt the big bald man, I'm ready. I'm I can make that work.
Perfect.
Yeah.
And will the quiz be just on the VFR and Prepper
No,
VORs? Okay, both.
both IFR, so it'll be in big
So
blue,
it'll
big
be-
red.
Yeah, so both, it'll be a two-part quiz.
Correct.
Okay,
Correct. Yeah,
great.
and that will be Wednesday.
Fantastic.
Okay. Well done.
Thank you.
That's that. Let's turn that off.